Hey everyone, on this lecture we are going to solve the problem 2 on the section of solve problems on queues. The name of this problem is hot potato game, and so the statement is write a function to simulate the hot potato game. In this game, children sit in a circle and an object, for instance a potato, is passed from one child to another. At a certain point in time, the object is stopped and the child who is holding the object is removed from the circle. The process is repeated until only one child remains, which is the winner of the game. The function will receive two arguments. First, the children sequence, that is, what are the children or the individuals that belong to the circle, and then the number of passes, that is, how many passes we will do until we are going to remove and eliminate someone. So here normally the hot potato game is played in real life with music, and when the music stops, then the child that is holding the potato or this object loses and gets removed from the circle. On this problem, what we have is a number of passes. Basically, we are going to do at each iteration a certain amount of passes, and once we've done and we've completed this amount of passes, the child that is holding the potato will get removed. For instance, here we have an example. Okay, here we have that the children, okay, are Alice, Bob, Charlie, David, and F, and we have 3 as the number of passes. So this is our circle, right? So we're going to begin from Alice. So the potato now has the potato at Alice, right? We have 1 pass. Then Alice is going to pass to Bob. So we have here pass 2, and then Bob is going to pass to Alice, right? So we have pass 3. So now the one that is going to get removed is Charlie. Charlie gets removed from the circle, right? Now we have 1 pass to David. Then David is going to pass to Eve, 2 passes, and then Eve to Alice. So Alice here holds the potato when we have 3. So Alice is going to be the second here child that is going to be removed. So in fact we can enumerate this. This is going to be the first child that is removed. This is the second. Okay, and we continue. Now the potato is passed to Bob, 1. Bob is not going to pass to Charlie because it is out of the circle, so it is going to pass to David. So we have pass 2, and David is going to pass to Eve. We have pass 3. So as we can see, Eve is the third child that gets removed. Okay, so here we can put the third child. Then the potato gets passed to Bob, right? Because Alice is removed, so we have 1. Then Bob passes to David. We have 2. And then David passes to Bob again. We have 3, right? So as we've done here 3, then Bob gets removed, and this is the 4th child that gets removed from the circle. And as we can see, the only child that remains inside this circle is David. So David is the winner of this hot potato game. That is why here on the output we see the winner of the hot potato game is David, right? So let's see how we're going to implement this problem. So to simulate the game, we will represent the circle of children as a queue data structure. The game will proceed by repeatedly dequeuing and inqueuing children until only 1 remains. So let's begin solving this problem. We create a new file, we go to save. We're going to save this file inside a folder called Lua in documents. So let's just here name this to be hot potato. .lua, this is the name of our file, we save. And now here we can begin by defining our function. Let's define here the function hot potato. This function is going to receive the children sequence, that is the children that we have on the circle, and then the number of passes, right? So we have here the number of passes. Now, as we've mentioned, we're going to use the queue data structure. So let's define first of all an empty queue. Initially it is empty. Remember that we define a queue using tables in Lua. And now the first step here is to enqueue all of the children. So here we have the children in that example: Alice, Bob, Charlie, David, and Eve. So we're going to enqueue all of them. We begin with Alice, then we go with Bob, we're going to enqueue Charlie, we enqueue David, and also we enqueue Eve, right? So this is the first step. So to do this, it is very simple. We just do a for loop, okay, from the control variable equal to 1 until the length of the children. So here we have a for loop, a numerical for loop. For I is equal to 1 until the length of the children, we are just going to enqueue the element at this position I. So we're going to use here the function table insert. We are going to insert this into the queue, and we are going to insert this element in here. Right, so this is the first step. And now what we are going to do in this algorithm is the following. The idea is we are going to begin a loop until only one child remains in the queue. And at each time that we around and we arrive to 3 passes, or the number of passes that we have in the input, it can be 3, it can be 4, 5, 6, right? Then we are going to dequeue the front element of the queue. So here the condition to keep updating the algorithm, and the condition that we know that we haven't finished, is while the length of the queue is greater than 1, right? Because while we still have more than one child in the queue, it means that we haven't finished yet, because the hot potato game only finishes when we only have one child in the queue, only one child in the circle. So now let's perform the passes from I is equal to 1 until the number of passes minus 1. What is very important here to bear in mind is that we need here to dequeue and enqueue passes minus 1 times and not passes times. The reason is that after passes minus 1 iterations, the next dequeue operation will remove the child holding the potato, which will leave then the correct winner at the front of the queue. So now here, this part is the most important part of the algorithm, because here many people get confused. Why do we need to dequeue and enqueue, okay, at each iteration of this for loop? Well, first of all, why do we need to dequeue? Well, when we dequeue an element from the front of the queue, we simulate the passing of the potato from the current child to the next child in this circle. So each dequeue operation represents one pass of the potato. Now, why do we need to enqueue? Well, after dequeuing the passes minus 1 number of times, the child who initially held the potato is not there anymore. But to continue the circle and ensure that each child gets a chance, we must enqueue the child back into the queue. So this enqueuing ensures that the child who just passed the potato gets positioned at the end of the queue, ready to receive the potato again in the next round of passing. So this is the reason why we need to dequeue and enqueue. Because by repeating the process of dequeuing and enqueuing, okay, passes minus 1 times in each iteration, we essentially rotate the queue. This rotation mimics the process of passing the potato around the circle. As a result, the child who is at the front of the queue after all of the iterations is the one who never got eliminated, and therefore the winner of the hot potato game. So now let's begin with the dequeue. Let's get this child, and we are going to here use the function table remove on this queue, and we want to remove the front element, so this is with the index 1, and then we enqueue this same element at the end of the queue. So we here insert in this queue this child that we have just removed, right? With this, in this example, essentially what we're doing is we are dequeuing the front element, which we can see here it is Alice. So we here what we're doing is we are dequeuing this front element, and then we are enqueuing, okay, this same element at the end of the queue, like here. This is the process that we have just done. So what can we say in here? Well, a very important aspect that we can say is that always the front element, okay, always the front element of the queue is the one, it is the child that is holding the potato. Initially it was Alice. As Alice passes the potato to Bob, now Bob is the front element. Okay, in the next process, Bob is going to pass to Charlie. So we are going to dequeue Bob. We dequeue Bob. We enqueue at the end Bob. And now since the front is Charlie, Charlie is the one that is holding the potato. Right, so always the front element is the child who is holding the potato. Okay, so with this we end this for loop in here. And now the next step is very simple. It is essentially we need to remove the child who is holding the potato. So let's define here the child that is removed. So local removed. And so what is going to be the child that is removed? Well, the child that is removed is the one that is at the front of the queue after we've done passes minus 1 times this loop in here, right? So we can just here remove the child that is at the front of this queue, basically with index 1, okay, after doing this for loop. Because after finishing this for loop, we ensure that the child that is the front element, is the one that needs to get removed from the circle. Essentially the one that is holding the potato. And even here we have an optional thing that we can do is we can print the one that just got eliminated. So we can print something like here, eliminated, and here we insert the removed child. So this can be useful to visualize how the children are going to get eliminated over time. Very well, with this we end this while loop, and with this we have this function. The last thing is we just need to return here the winner. So the last remaining child here is the winner. Right, so let's define here this variable winner. This is going to be basically the queue with index 1. This is the last remaining child. And here we can just return the string the winner of the hot potato game is, and we concatenate this with the winner, right? So basically if it is David, this is going to print David. If it is another child, this is going to print the remaining child, which is the winner. And with this we end this function definition, right? With this we end here this function definition. At the very beginning, very important also that we close this for loop. So let's close this for loop with the end keyword, right? So with this we end this for loop. With this we end this function hot potato, right? We end this function definition. So we save, and with this we have everything. We are ready to test this function. So let's verify that this function is working right. We open the terminal of our operating system. We open the Lua interpreter in the same directory, the same path where we have saved this file, the hot potato file. We can load this file with the do file. We're going to load this file. The name of this file is hotpotato.lua. So we load it. And now we can verify that this function is working right. So first of all, let's apply the function with this input here. The children that we have are Alice, Bob, Charlie, David, F, and number of passes is 3. So we apply the function hot potato. Remember that the name of the function is hot_potato. Here we pass the sequence, and the number of passes is 3. So we press the enter key, and now as we can see we have precisely the same output. The winner of the hot potato game is David, right? And in addition we have here, okay, the function returns this value, which is the output of the function, but we also have here the printing, the display of the order of elimination, how children got eliminated over time. First it was Charlie, then Alice, then Eve, and then Bob. But we can try also this function with another sequence. Let's suppose here I have another child. Let's just suppose I have here top, and so now we press the enter key. Now as we can see, for this case the winner of the hot potato game is Alice. First Charlie got removed, then Top, then David, then Bob, then Eve, right? So with this we have the implementation of this function to simulate the hot potato game, and we end the solution to the problem 2. We remind the student that you can download the solution as well as the problem statement on the downloadable documents of this lecture.